Hello everyone. In today's video, I'm going to discuss about significant figures. A significant figure, sometimes referred to as a significant digit, or simply sig fig, is a measured or meaningful digit of a number. The number of sig figs can vary depending on how accurate an instrument is able to measure. In this video, I'm going to talk about the rules for determining the number of significant figures. And also, we're going to talk about operations with significant figures. So the rules for finding out the number of significant figures. Number 1, all non-zero digits in a number are significant. Here's an example. The number 345 has 3 non-zero digits. Therefore, they are all significant. And the number 345 has 3 significant figures. Number 2, zeros in between non-zero digits are significant. For example, 5,023. The 0 is in between 5 and 2. Therefore, that 0 is significant. And 5,023 has 4 sig figs. This rule also applies for decimal numbers. For example, 34.003. Those two zeros are between 4 and 3. Therefore, they are also significant. So the number 34.003 has 5 significant figures. Rule number 3, leading zeros are not significant. This rule mostly applies to the decimal numbers. Here's an example, 0.003. The 3 zeros are in front of the first non-zero digit 3. Therefore, they are considered leading zeros and are not significant. So the number 0.003 has only one significant figure. Rule number 4. Trailing zeros after a decimal are significant. Let's look at an example. 5.6700. Those two zeros are placed at the end of the number, but it is after a decimal point. Therefore, they are both significant. So 5.6700 has 5 significant figures. Rule number 5. Trailing zeros before a decimal are not significant. Here I have 3,400. The two zeros here are before a decimal point, and therefore these two zeros are not significant. So the number 3,400 has only 2 significant figures. However, there is an exception to this particular rule. If there is a decimal point awkwardly placed at the very end, then those zeros will count as significant. I'll use the same number here. I have 3,400, but this time I have a decimal point placed after the last 0. Because of that decimal point, that makes those 2 trailing zeros before a decimal point significant. Therefore, this number, written with a decimal point, has 4 significant figures. Here is a summary of the rules to determine the number of significant figures in a number. Now, it's your turn to practice. Here are 10 numbers on the screen, and you can find out how many sig figs are there in each number. You can pause the video. On the next slide, I'll show you the answer to each of these. Now, let's talk about operations with significant figures. When we do operations, we're going to split the operations into two categories: multiplication and division, and addition and subtraction. So let's start with multiplication and division first. The rule for multiplication and division is that when you find the answer to these calculations, you will round to the number with the least number of sig figs. So let's look at an example of multiplication. 3.65 times 4.792. This gives us the answer 17.4908. When we determine how many sig figs are in our final answer, we have to look at how many sig figs we have in each of our numbers. So 3.65 has 3 sig figs, and 4.792 has 4 sig figs. In multiplication and division, we're going to round the final answer to the number with the least number of sig figs, which is 3.65, that has 3 sig figs. So the final answer will be rounded to 3 significant figures. Therefore, the final answer with the correct number of sig figs is equal to 17.5. Let's look at another example, this time a division. We take 36.75 and we divide this number by 2.3. And this will give us 15.97826, and so on and so forth. Let's also look at the numbers of sig figs that we have. 36.75 has 4 sig figs, and 2.3 only have 2 sig figs. Therefore, our final answer needs to have 2 sig figs. And to round the final answer to 2 sig figs, this will give us 16. So that is the rule with multiplication and division. Let's look at addition and subtraction. Addition and subtraction is a little different. The final answer to the addition and subtraction needs to be rounded to the number with the highest place value as its last sig figs. So let me use a couple of examples to explain this rule. 3.85 plus 2.7. When we do addition and subtraction, it's a lot easier if we write the number in a vertical manner to show the sig figs. So we have 3.85 plus 2.7. And we can see the final answer give us 6.55. Out of the two numbers, 2.7 has the last significant figure on its 10th place, whereas 3.75 has its last sig figs on the 100th place. Therefore, when we round the final answer to the correct number of sig figs, we have to follow this highest place value as the last sig fig, which is this 7 in the 10th place. Therefore, the final answer needs to be rounded also to the 10th place. So the final answer, when we round it to the right number of sig figs, is equal to 6.6. Subtraction works exactly the same way. So let's use an example. 15.7 minus 13.938. Again, we can write this in the vertical manner. 15.7 minus 13.938. And if we simply do the calculation, we get the answer 1.762. To determine the number of sig figs we have for our final answer, again, we need to look at the last sig fig and to find the highest place value. And it's easy to see this one as well. The 7 is the last sig fig with the highest place value here on the 10th. Therefore, our final answer is also rounded to the 10th place. So the final answer for this one is 1.8. As you can see, addition and subtraction, sometimes when we do the calculation, will make the answer have less significant figure than either number you started with. What happens when you do a mixed calculation? I'm going to use an example to show you how we calculate a mixed operation. 24.53 times 0.759 plus 158.4 times 0.27. When we do a mixed operation, we always have to follow the proper operational order. So in this case, multiplication comes before addition. So we will do the 2 multiplication first. In the first multiplication, we get the answer 18.61827. In the second multiplication, we get 42.768. It is worth note that at this step, it is important not to round your answer to the correct number of sig figs, but to keep track of the number of sig figs in each of the answer. So in the first multiplication, 0.759 has only 3 sig figs. Therefore, our answer should have only 3 significant figures. And I'm going to use the red underline to indicate those are my significant digits. In the second multiplication, 0.27 has only 2 significant figures. Therefore, in the answer to that multiplication, only 2 sig figs can be used. So those are done according to multiplication and division rule. Now we have an addition. So we will continue with the operation using the number without the rounding to get our final answer. So the final answer we get is 61.38627. And with that, we will apply the addition rule to figure out how many sig figs we have in our final answer. And in this case, 42 has its place value of the last significant figure in the unit place. And that is the highest. So therefore, we will round our final answer only to the unit place. And in this case, that gives us the answer 61. Okay. Hopefully, this example shows you how mixed operation with significant figure work. Okay, so here are some practice questions for you to do. Again, you can pause the video right now and work out the solution on your own, and I will show you the answer in the next slide. If you find today's video helpful, please like and subscribe. Also, turn on notification so you won't miss our new videos. See you next time.